So you're back for more math. Hey, that's okay. It's okay if you can't get enough of it. Here we are. This is Unit 10, Day 5, percent error. And this lesson could seem a little bit difficult, but we'll break it down into some simple steps. Alright, so your learning target is I can use absolute and percent error to solve problems. These are terms probably that you haven't heard before, and that's totally okay. So let's talk about absolute error. This measures the difference between the approximate or accepted value and the exact or the measured value. So today we're going to be talking about two different things. Let me use yellow here, I hate when it does that. Never mind. So we're talking about the accepted value or the approximate value versus the exact value or the measured value. So you could use two different terms. And right now this might sound a little bit confusing or too much, but don't worry, we'll talk about it and get more into this. All right, the next thing, it can be solved by finding the absolute value of the difference between the approximate value, A, and the exact value, V. There's one word here that I really want to stand out, is the word difference, because we're going to focus on that one. So they said here that we're going to find the difference between A and V. Here's what that looks like using absolute error. Now, we talked about absolute value at the beginning of the year, and that's when you have these two bars that no matter what you do on the inside, your answer will always come out to be a positive number. So we have to find the difference, that means subtraction, of A, the approximate value, and X, the exact value. And we're going to use that equation later on, or anytime that you're asked to find the absolute error. Alright, so this question says, use your understanding of absolute error to answer the questions below. So question number 1, a science experiment calls for 150 milliliters of water, but Simon measures out 147. What is the absolute error? So we would take the approximate value, which would be 150, and we need to subtract the exact value. Well, the exact value is what he measured out, which was 147. And if we did that math, 150 minus 147, that gives us 3 milliliters. Here's what I want you to know. Actually, we'll move on to number 2, and then we'll talk about this. All right, question 2. A student measured the mass of an object to be 56 grams, but the actual mass was 53 grams. What is the absolute error? So the approximate is going to be 53, and we're going to subtract the actual, the exact value, and that's going to be 56. And 53 minus 56, that gives us -3, but the absolute value of -3 is just 3 grams. Now, when I first went over this, I thought, well, why aren't the numbers the other way? Shouldn't it be the other way? That was just me. It just didn't make sense to me the way that things were set up. But as I looked at this, I noticed that if you did 56 minus 53, you would get the absolute value of 3, which is, once again, 3. Notice here we get the same answers. If I were to do the same thing on this other side, 147 minus 150, I would get the absolute value of -3, which gives me 3. Your answer in absolute value always comes out to be a positive number. So no matter what you're subtracting, at the end of the day, you're just finding the difference. And the word difference, we've talked about this so many times, the word difference just means subtraction. So subtract the two numbers, and what's left over, that's going to be your answer. Anytime we're talking about absolute error. Let's use a different color. So, like I said earlier, anytime they're asking about absolute error, you just find the difference between the two numbers. That should be pretty simple. Normally we like to make things harder than it is, but it's not too hard. Okay, next question, or next topic that we're going to talk about. This one says percent error, which is a whole new topic. We'll do red. percent error compares the absolute error to the exact value. So here's an example when you're calculating the mass of an object in science. I know that you guys are in a science class, you probably calculate the mass of an object, measuring the distance of an object that an object has traveled, etc. So there's many times that you will be finding percent error. And to most people, this is a topic that is like totally new. You haven't heard of it before. So that's what we're going to go over it. Percent error, it can be solved using a percent error equation in which the values are plugged in to the formula below. So this formula is super important. We're going to be using it throughout today's lesson. So here's what you do. Percent error is equal to the approximate value minus the exact value. That's exactly what we were doing before, over the exact value. So just put that below. Once again, I'm looking right up here at this equation. It's super important. It also says, or you could use this equation and they will give you the same exact thing. Now right now this might look like a bunch of mumbo jumbo, but we're going to put it all into play and then you'll see how important it is. So question number 3 says, during a school assembly, Mrs. Quinn takes attendance and counts 356 students. In actuality, there were 376 students. What is the percent error? So we have to take the approximate students, 356. I don't know why I started with the 5. It's late, guys. 356 minus 376. And we have to use absolute value lines because that's what our equation is calling for. Then we're going to put that over the exact value. Well, there were 376 students, so let's put that number on the bottom. Okay, now the next thing that we have to do is set it equal to, well, that will give us the percent error, or it will give us a percentage, which is always out of 100. So let's go ahead and do this math right here, see what we end up getting. 356 minus 376, that gives us the absolute value of, well, that would be negative 20, but that ends up equaling, I didn't have to draw that line. That ends up just equaling 20. So here's what we have. 20 over 376. Well, that's going to give us the percent error. What does 20 over 376 give us? Let me get my handy dandy calculator. Sorry, I didn't have it ready. All right, I'm typing in, what does 20 divided by 376 give me? And it gives me 0.053 and a bunch of decimals. Now, what we're going to do is, it says up above, well, in order to get a percentage, you have to times it by 100. So I'm just going to take my answer and times it by 100. This was kind of the same setup that we've had before. Let's see, I think it would have been the last lesson that we did in this class. Okay, so let's just times that answer by 100, and that gives me 5.3. So that means a percentage. And here's how I know that. Because up here, let me circle it really big. It said we would have a percent over 100 set equal to this stuff right here. I guess I could have just written it up higher. Percent over 100. So all we're doing right now is using our equation, and I got 0.053 over 100 equals 20 over 376. Well, in order to get my percentage, I just had to times by 100. So I actually got 5.31. 1. So I'm going to erase all of this, and I'm going to put my answer was 5.31%. Okay, I think that looks pretty good. So x is equal to 5.31%. Okay, let's go on to question number 4. I'm going to erase just a couple things. Question 4 says, in a crowded sports arena, 250 seats are counted. If there is a 20% error on the count, what is the range of acceptable number of seats? Well, this time we kind of have to work backwards using the equation that we've been given before. They give us a 20% error to start with. And now we have to move backwards. So we don't know what x is, but we do know that our exact value is 250 seats. So let's put 250 seats on the bottom. Now we have to set this equal to the percent that they give us. They said that there's a 20% error. Well, if we were to write that in a fraction, that would be 20 over 100. And now we just have to go ahead and solve this like we would any proportion. Yeah, so let's go ahead and try that. I like to do, and I know I've talked to you guys about this so many times, I like to do 250. Oh no, it's doing the wrong color. This thing is so crazy. Let's see if we can do this now. Yay. 250 times 20 divided by 100 will give us our x value. So let's see what I end up getting. 250 times 20, I'm typing this in my calculator, equals 5,000. Now I have to divide that by 100 equals 50. So once again, this is all that I did. 250 times 20 divided by 100. That gave me my x value, which is 50. So what we're saying here is that x equals 50, because that's what I just barely got when I did all of that math. I can even plug in 50 up here for my equation. What they're asking us though is, what is the range of acceptable number of seats? Range means you add or subtract your x value to the exact number of seats that we had. Well, our exact number of seats was 250. So now we need to add 50 to that, and we need to subtract 50. If I add 50 to 250, I'll get 300. If I subtract 50 from 250, I'll get 200. So I'm going to switch colors here again. I'm going to put right here, range that we're going to have is 200 seats to 300 seats. All we've done is taken our x value and we add or subtract it to our exact number of seats that we had before. Okay, so you may have some questions like this on your homework. Please use these ones as a reference. It's kind of tricky, but the more you practice, the better you'll get. All right, next question. Read each of the situations below and answer the questions using your understanding of absolute and percent error. I really like absolute error. I think that stuff is really fun because you just take the difference. You're just subtracting. And then percent error, we just take that one at a time. So question number 5 says, several students are competing in a science club competition to build a car that will travel exactly 10 meters. Exactly 10 meters. The distance each student's car traveled is shown in the table below. What's the absolute error of each race car? Well, absolute error we talked about before is just the difference. And I'm going to write that up here. Difference means subtract. So we need to find, let's go back up to that equation. Wow, I have a lot of drawings up here. Okay, we had a minus x. I'm going to switch over to another color. We had our approximate value, subtract the exact value. And that was the absolute value of a minus x. We were just finding the difference. That's all that we were doing, and our answer always comes out as a positive number, no matter what. So take the approximate value, subtract the exact value. Well, this question down here says our exact value is 10. So we're going to take the approximate value, subtract 10 from it. So what's the absolute error of, let's start with Emily's race right here. I would take 9.2, sorry, not 9.2, the absolute value of 9.2. And I would subtract my exact value of 10. Now, when I do that, I'm going to get the absolute value of negative 0.8. Let's see if that's correct. 9.2 minus 10 gives me negative 0.8. Well, that just gives me a positive 0.8. So your answer right here, what's the absolute error for Emily, is going to be 0.8. Now, how about Jerome? We would do 10.6 minus the exact value, which was 10 meters, and we have to do absolute error. So 10.6 minus 10 gives us 0.6. And then the next one is Maricela. We have to do 9.8 minus the exact value of 10, and that's going to give us the absolute value of negative 0.2, which gives us 0.2. So that was Maricela's absolute error. Okay, so what is the percent error of each race car? Well, I'm going to bring you back up here to this equation right here. What we've already done is the top part on all of these. We took the approximate value minus the exact value. Now what's left is to find the percent error. We have to put our answer over the exact value and then times it by 100 to get the percent. Let's go ahead and try that. So if I got 0.2 from Maricela, I would put that over the exact value, which was 10 meters. I know 10 meters because I'm getting that from up here. And I have 0.2 because I'm getting that from right here. So now I need to figure out what my answer is. Whatever answer that gives me, I have to times that by 100. So let's go ahead and try that. 0.2 divided by 10 gives me 0.02. And now I just need to times that by 100. And I got 2. So what that means, that gives us a percent error. And I got 2%. So 2% would be my answer right there. I'm going to leave that work because I think it's really important. But my answer would be 2% for Maricela. And I'm going to write the work for Jerome just down below so you can see it all. Okay, for Jerome, so we have to take the answer up above, which is the absolute error. To get that, we did all this math right up above. So I'm going to take 0.6 and I have to put it over my exact value. And then whatever answer that gives me, I'm going to times that by 100. And that's going to give me a percentage. So 0.6 divided by 10 equals 0.06. And now I need to times that by 100. And that gives me 6%. Where am I getting all of this from? I'm just getting it from up above on that really important equation that I taught you. So if you're getting stuck on any of this stuff, let's switch over to a different color. You're going to use this equation. Always take your absolute value. Oh no, it's the wrong color again. I'm telling you guys, this is so tricky. You have to click this text box up here first. Okay. You have to take the absolute value of your approximate value minus your exact value Whatever you get, divide that by your exact value, and that is going to give you a percentage. In order to get the percentage, you always have to put that number. It's always going to be out of 100. So if you get a decimal, times it by 100. So this is a very important equation, and that's what I'm using on all of these questions up above. Anytime that it asks you for percent error, okay? Let's go ahead and try to fill out what's Emily's percent error of each race car. Well, in order to figure out Emily's percent error, we have to use this 0.8 that we have. To get the 0.8, I'm going to break this one down kind of slower, okay? If I were using this equation that I have down in blue in the bottom, I would say that we would take the approximate value minus the exact value, and we've actually already done that before up here. So 9.2, the absolute value of 9.2, minus the exact value of 10, all over 10, and that's going to give us a number out of 100, and then we turn that into a percentage, okay? That was me like breaking it down and really writing out the equation for you. Well, let's go ahead and do that. 9.2 minus 10, if we did the absolute value of all that, we'd get 0.8. I know that because we wrote it up above earlier. So 0.8 over 10, and then I just have to times that by 100. 0.8 divided by 10 gives me, what the heck, where did that go? 0.8 divided by 10 gives me 0.08. And now all that's left to do, 0.08 out of 100, that's going to give us a percentage. No, that gives me 8%. So what that means here, Emily's percent error is 8%. Okay, the next question for part C says, based on this information, what does a small percent error indicate? So yeah, this one's really important. A small error would indicate that, I'm going to put this down, and if you have notes, I want you to write this down too. The car is built closer to the needed specifications. Sorry about my handwriting. And can travel very close to 10 meters. So percent error is not really a good thing to have. A smaller percent error is much better. Okay, so for part D, it says mark each of the following statements as true or false based on the data. Jerome has the smallest percent error. Well, percent error, I'm looking up here at part B. Jerome has 6%. Maricela has only 2%, so I'm just going to say false. Next one, Emily's race car was the most accurate. Well, the most accurate means it's going to have a smaller percentage of error, percent error. She has the largest percent error. So hers was definitely not the most accurate. So I'm going to say false. Next one, Emily and Maricela had a negative percent error because their cars traveled less than the desired distance. Let's see. This percent error is positive and this percent error is positive. So that's not negative. I'm going to say false again. All right, now question 6. Mr. Brown's class was guessing the number of gumballs in the gumball machine in the cafeteria. Of all the guesses, all of the guesses were between 382 and 456. After counting, it was determined that there were actually 408 gumballs in the machine. Here's what I want you to focus on. They give us the exact number, 408, okay? So what is the absolute error of the guesses below? Well, we have to find the difference. Absolute error, this one is always just find the difference or just subtract them from each other. If you want to use the equation, you can. You would set it up and say, what was the approximate number minus the exact number? And you put it in this absolute value lines, and it looks like this. So my approximate value would be 382, and my actual value would be 408. And then whatever you get out, it has to be a positive answer. 382 minus 408. I better try that one right now. On my calculator, that gave me negative 26. So the absolute value of negative 26, that's actually positive 26. Or you could have just done 408 minus 382. I'm going to do the same thing on the next one. I'm going to say, what's 456 minus the actual number, which is 408. So I'm going to say, what's 456 minus 408? And that's going to give me 48. For part B, what is the percent error of the guesses below? Now remember, for percent error, you have to use an equation. So I'm going to go ahead and write it out here for you. Let's switch up the colors because I'm getting sick of this one. Red. There we go. It did it again. Okay. So to find the percent error, you have to take whatever number you get. So whatever number you get from absolute error, in this case we got 48 and we got 26. That number, you're going to put it over your exact value. Our exact value is 408. So you have to use that equation. What was it up above? Let me go to the very beginning again. Your approximate value minus, exact value, V. Wait, let me check my notes really quickly. I wonder why my notes have an X in it. So take your, I guess we could have put a V right there. Take your approximate value and the exact value. And you'll notice I've put an E there. You can put whatever you want as long as you're doing the math right. Approximate value minus my exact value. Well, we've already done all of that. That's where my 26 and my 48 came in. And then whatever answer you get is going to be a number out of 100, which then turns into a percentage. So let's do, what happens if I do 26 divided by 408? Whatever I get is going to be a decimal. Let's times it by 100 and get a percentage. 26 divided by 408 gives me 0.063. Now I just have to times that by 100, and I got 6.37%. And you can just round that up if you wanted to. That could round up to 6.4%. All right, let's go ahead and fill out the next question. What if we used 48 instead of 26? We still use the same exact equation. When we took the approximate value minus the exact value, we got 48. So let's do 48 divided by 408. That gives me 0.117. And since we got 0.117 out of 100, we just have to make that into a percentage. Take 0.117 and just times it by 100. and that gives me 11.76%. Well, what can that round to? 6 is going to round up, so that means we have 11.8%. Okay, I'm sorry if this video was so long. Please let me or Mrs. Morris know if you have any questions. We're more than happy to go over this stuff with you. And yeah, we're looking forward to hearing from you. Have a good day.